This conference will now be recorded.
Thank you for everyone joining today. This is Charlie with S&S Solutions. We are privileged here to have Eric Williams from S&S Solutions to discuss optical loss testing. Eric has an extensive background in the communications industry. He's been with S&S for about 4 years now, where he's the territory sales manager up in the Northwest, and is also one of our trainers for doing product demonstration and after sales support training and other sorts of training that we do. Before coming to S&S, Eric was with Ericsson as a quality assurance manager, where he also then moved over to project management. Overall, he has about 15 years experience in the industry, very knowledgeable in the testing realm, splicing, Ethernet, fiber, and in the wireless industry. So without further ado, I will turn it over to Eric.
Thanks, Charlie, for that kind introduction. Appreciate it. So, guys, I'm really excited about this presentation today. We get a lot of questions about loss testing, insertion loss testing, optical return loss, and I wanted to try to clear up some of the methods primarily that we use to achieve those testing. So I kind of want to talk about the simplest, down and dirty, kind of lowest cost way to perform insertion loss testing. First, we'll talk about some of what insertion loss testing actually means. And you can see on your screen here, I'm basically just sharing my desktop with you guys. I'm using the Fiber Optics Association reference guide, and we'll send out a follow-up sheet with some of these links that I'm looking at here. But we're a FOA accredited school, and that's some of the training that we actually perform. So it's pretty easy to use their material, and it is available on the web for you guys. So I definitely suggest using that as a resource if you ever need a reference back for questions about, say, what's the difference between DV and DVM. All of that information is located right there on the FOA Guide to Fiber Optics. Not the flashiest website, but definitely the best resource for information on fiber optic testing, cabling, pretty much anything I've been able to find right on the FOA Fiber Optics Guide. So today I'm going to kind of be referencing back to our insertion loss testing lab and some of the insertion loss testing actual pre-test, our virtual hands-on. So there's just a couple slides in here that I wanted to reference back to, but mainly we'll be talking about the actual equipment and achieving that insertion loss testing. And what I really wanted to focus on was the ways to achieve a solid reference and what the downfalls are for certain methods, and what's maybe the best method to use. So as I'm going through this, feel free to use the chat box, and if you have any questions or if there's anything going on that technically that we may need to address. So starting out here, I mainly want to talk about insertion loss testing because ultimately that's kind of the very basis for testing. If we go way back to when we first started installing fiber, realistically, we just wanted to know how much loss between the source optic and the equipment that's going to be receiving that optical signal, how much power relatively is needed for that equipment to operate, and will that network be able to attain that? So it's pretty simple chart up here. We have our electronic interface or our optic here. Depending on whether it's multi-mode or single mode, it's going to be a different type of optic, obviously. And then we have our fiber or our actual plant that we're going to be traversing to get the light across. This plant generally is going to be obviously the fiber itself, which has some attenuation that we need to understand. It should be, depending on the wavelength, 0.35 or 0.25 per kilometer at 1310 and 1550. Obviously, it's going to be a little bit different at 1625, or if you're doing multi-mode at 850. But we're primarily going to be talking about single mode testing here today. So really, we're just looking at the actual system's operation, so the total loss. And that gives us a good point of reference because as a installation or as a design engineer, you're focused on the total loss or the loss budget for that plant between the source and the customer premise equipment or whatever equipment you're trying to reach. So really, that's kind of a good base knowledge. Now, as OTDR technology became higher resolution, lower pulse widths, basically better overall, that type of testing has kind of taken the forefront, whereas loss testing was kind of the primary. And then also bidirectional loss testing, so looking at the loss from either direction, because we are transmitting and receiving from both ends. So this is a real basic, a diagram of our fiber plant. We will have loss at each of these events. So a connector is going to have a certain amount of loss. That's also going to have the optical return loss, which is essentially reflection from that connector in phase. There will be splices as well. So a splice will have additional attenuation, a little bit more loss than just the fiber itself, unless we are getting some really good splices out there that are very low loss. And then there's generally going to be a way to connect to that fiber at the far end. And some of the things we're going to talk about today is like, what kind of connectors are we using? What kind of connectors does our equipment use? And how do we reference out cables to work with the compatibilities of those connectors? So today I'm going to look at mainly SC-UPC and SC-APC. Of course, there's still a lot of plant out there with ST connections or LC or variations. And we'll kind of talk about how to get a good reference if you need to use a conversion cable and making sure that you reference out that cable properly and the different methods for referencing the cable. So on the very basic, I'm going to switch over here to my workbench, follow along with me. So at the very basic, and this is actually not even that basic. This is EXFO's latest and greatest, the PX1. It is a optical power expert. Essentially, it is a power meter. There are lower end, more affordable power meters out there. The PX1 does afford some additional advantages in being able to get your power levels and recordings off the unit relatively easy. The Pro model also includes a VFL, which is pretty effective as well. But ultimately, this device measures the power of light in either a relative or an absolute way. So an absolute power is just going to be if I take this guy to the end of my active network and I plug it in and I check to see whether it's high powered or low powered. And then there's also a relative power, and that's relative to a source. And that's the other portion of our system, our basic system here. And I'm using the FLS 300, the fairly basic source. It's battery powered, fairly easy to use. I'm going to look at the 1310 wavelength here, and I'm going to make sure to set my power meter also to 1310. Quite a few wavelengths here. So if I just plug this cable plant here, for instance, right into my power meter, and I went ahead, just so that we're clear here, one of the key components to any testing, and you hear us harp on this over and over, and especially with loss testing, because we get a lot of loss in our connectors. So one of the key things that we need to do is make sure everything is nice and clean and has been inspected. I did spend some time this morning pre-inspecting these connectors, so I wouldn't take up too much of your time doing the inspections, but I will just take a look at this guy to start with. So we want to make sure our connectors are nice and clean and scope well. I'm also using reference cables that are basically brand new. When I pulled these guys out of the bag, I still scope them because I found even a little bit of dirt that had accumulated either from under the desk caps or sometime in transit. So I want to make sure and clean and scope all of the connectors. and all of the interfaces on the test equipment. Now, we can see that I've got my source here, and absolute power on that is roughly 4.75 dBm. Now, to measure loss, I need to take an additional step. I need to actually reference out and zero out this unit, and then attach these reference cables to a cable under test. When doing this, I really need to make some decisions about how I'm going to be able to connect to my fiber under test. I need to have some sort of cable connecting between the device itself and the source. Now, in this case, we're going to be testing a piece of network in my network simulator here that is essentially new construction. We don't have any equipment at either end. There's no light source on the fiber, so we don't need to be referencing it against that light source. We're going to use a known light source, the FLS 600 or 300, and I'm going to reference this out here, and basically there. So switching over to relative power, I can take a reference and as I was stating, I've got one fiber that I can use to connect to the plant, and then I'm going to need another reference fiber or some sort of cable to connect between the meter and the fiber under test. So I'm going to have to use, and actually on my plant here, I have a little bit of a scenario that's similar to what you guys probably see. And I can't show you but through the cameras, but essentially I have an APC connector at my customer or at my equipment side, the CO side, and then out at the CPM side, I have a UPC connector. So that presents a little bit of a problem, because if I have, say, SCAPC cable, reference cable here, I'm going to connect that to my CO side with a source. It's essentially going to work as my CO equipment. I'm going to connect that over here to my plant. And now I've got a meter, and if I'm using a reference cable with an SCAPC to SCAPC, I need to reference this cable out so that I have zero loss in the reference cables. And we can kind of discuss that if anyone has any questions on that. But there's a single cable reference method, a 2-cable reference method, and a 3-cable reference method. Excuse me. So in this situation, I need to have a cable that goes, a reference cable that goes between my equipment and the customer equipment. So I'm using an SCUPC or an SCUPC and SCAPC. And like I said, I went ahead and pre-scoped these so I don't have to take up too much of your time now. So now I've got my meter and a cable that I'm going to connect to at my customer premise equipment, and I've got my source with a meter that I'm connecting to the equipment and my CO. But the problem is I've got 2 different connector types. So in order to reference both of these cables out, I actually need to use the 3-cable reference method. And in that situation, we need a conversion cable that's going to work between our SCAPC and SCUPC. And I need that to be a perfect low loss, what we would call a golden reference cable. And it needs to have the connectors that work with either end. And I thought I had a third one out here. Now, one thing that I like to do when I'm working with these reference cables is, as I pull them out of the bag, if I'm going to keep them in with my test equipment, just quickly write the date that you pull this guy out. So today is 3/31 or 4/1. And that way I can kind of keep an idea of how often I've used this or how long I've been using it. So and we're going to have to use a couple bulkhead adapters to be able to connect our reference cables. One question I always get is the difference between these two pieces of material. Outside of color, there's really no difference. There is some manufacturing differences between the different connectors, but really I can use a blue adapter with a UPC or APC connectors. It doesn't really matter. What does matter is that we use the correct color on the bulkhead itself so we don't cause any confusion. So now I have my golden reference cable. I'm going to connect up here and reference out. And we're basically just using this as a stand-in for our plant. And then I'll connect it on this other side. And that's why we call it the golden reference cable, because we want it to be a known low loss cable. All right, so this is my 3-cable method here. Got my unit. I'm gonna power up, and let's see, I'm going back to, I've already set that previous reference, so it's a little bit lower loss with this golden cable in. So I take that reference there. All right, and now we're zeroed out. So now I can quickly turn my light off. Now I can remove this golden reference cable out of the equation. I'll really quickly protect these so I know they're nice and clean. And now I can connect to the actual plant. So this is where your technician's going to be moving, from the CO or wherever the equipment is out into the field. And they're going to connect their equipment. And we're going to quickly scope this guy before I connect it. Oh, that's going to be a problem. I use the correct tip. Yeah, good thing I scoped it because we do have a good little booger on there. See if I can clean that up real quick. That looks much better. So. Perfect. All right, so we'll go ahead and connect the meter to the premise side and my source over here to the CO side. Now, going to 1310. All right, I can actually see that I have quite a bit of loss in this plant, nearly 23.75 dB. So I'm gonna write that down because we're gonna use it with these other additional methods. Now, in this cable plant, what you can't see here is I have about 3,000 meters of fiber with 2 1/8 splitters that are roughly 10 dB of loss each, and a splice that's a little bad somewhere in the middle there. A couple splices that aren't looking too good. So the expected high loss from what I know about the plant is there. But I wanted, like I said, I wanted to make sure that we understood the reference method, because I'm using a couple different connector types. I see that often, that question coming up in the field is like, how do I connect everything? Now, one of the key components to using that 3-cable method is that I'm actually calculating the loss of those connectors. And that's important, because without that loss of those connectors, there's a certain amount of uncertainty, because when we reconnect that outside plant to the customer premise equipment and to the CO equipment, we're going to have loss on those connectors that we weren't able to record unless we actually reference out the connectors that are connected to them with a 2-cable method. So now to do a bidirectional loss, I can actually, swap my source and my meter. Now, pretty simple method here, because I've got everything right in front of me, including my, 3,000, almost, 3 kilometers of fiber. But in reality, moving these pieces of equipment to either end of the plant after storing and referencing storing all of your files through the multiple fibers that you're testing, and then taking this device to the CO side and your source over to the customer premise side, and looking at it in that direction is going to give you a bidirectional loss, in which case you're still going to have to store all of those files on your power meter, and then later on reference fiber 1 to fiber 1 from A to B and B to A. It gets pretty complicated. So that's where some of these additional optical loss test sets or other methods have come into play. And we'll talk about that in a little bit, but realistically, the optical loss test set is a little bit anticlimactic, because it's doing so much in the background to eliminate a lot of this additional work. So now that I've got, we'll say, call this fiber 1, A to B, now I would actually physically move my meter from this end of the test, in which case I'll need to change and re-reference, because now I've got a SC-UPC cable to an SC-UPC at the customer prem. And then on the other end, I'll have an SC-APC. Now, the meters are typically, they are agnostic as to the type of connector that you use, because they don't have a mated fitting. In this case, I don't know if you guys can see down in here, it is a SC connector, but there isn't a ferrule in the actual meter itself. It's going to be the same for the meter that's on my, any of my power meters on my OTDR, FTB, or the power meter on my FTBX 945. All of them have a connector type versus a universal. However, they're not actually connecting to a ferrule. So they're agnostic to the whether it's an angle polished or single polished, just need to match up the actual connector type. So any questions from you guys on using the standard power meter and light source for doing insertion loss testing? All right, didn't see anything come in. Now, like I said, this is a great piece of equipment if you are looking at power for an existing network that's already been installed, and you just want to check the relative power or absolute power rather from the source. In this case, it's actually a fiber light source, but it could be a number of different items, whether the customer premise equipment or some other source from your OTDR or something. But typically it's going to be from your CO equipment. Now, you could also use a simple power checker to accomplish the same thing, but we're not going to have the same level of accuracy as an actual power meter. So power meter, super handy, great for fiber to the home technicians to check for power. They can do some referencing and some absolute or relative power readings. But if you're installing plants, and it's brand new. What has become the industry standard is an optical loss test set, which is, excuse me, over here, which for EXFO is the either the FTB or the Max Series 945. And essentially that consists of a power meter and a source in one unit that couples with a power meter or source in the other unit. And I wanted to reference back really quickly to the test method we are using. So this is similar to what I'm looking at here: source, cable to test, and a reference cable. So this is the 2-cable reference method when we have connectors that are the same here and here. Very, very easy to utilize. I'm going to scroll down a little further into this presentation and talk about the 3-cable method, which I believe is method C. Yeah, here we go. So we're referencing 3 cables. The third is the gold standard. That's that one reference cable that I'm going to keep in good working order and know that it has a low loss. And this is where the connectors on either end may be different, that you need to utilize a 3 cable reference method. And there are, positives and negatives to all of these methods. There's really a great loss difference between the 3 reference methods within our hands-on training, and it shows the losses and results from the different methods. So the cable reference method with a single cable or 1 cable reference, we have the lowest losses, because this actually should be a negative number, a 2.96 dB, which would, the reason this one is lower than the 2-cable reference method, but the 2-cable reference method, remember, we are actually looking at the cable ends on those 2-cable reference method versus a single cable reference method, which only looks at the cable and doesn't reference out the connector itself, because when we reference the cable, the connector is not connected to anything. So for the most accurate, however, you are going to have a certain amount of uncertainty because of the 2-cable reference method. You do need to make sure that your in-faces are absolutely perfect and clean, so you're not getting any additional loss from the connector in-faces of the reference cables. So, and quite honestly, for most of the practical uses out there, the 2-cable reference method is going to be the best option. There is another reference method on the OLTS called a loopback reference method, which is essentially a way of referencing a single cable to the unit itself. And I know that a lot of folks use the loopback method, and I believe it is accepted by some carriers. I know a lot of contractors use it. I still recommend trying to do a 2-cable reference method whenever possible. So I'm going to shoot back over to my OLTS. And first thing we're going to do with the OLTS, so I'll start here from the mini toolbox. I'm on an FTB1, and I have an FTBX 945 module. I've launched the OLTS software. And to be able to, whenever I start, I need to set a new reference. And one of the beauties of the FTBX 945 is it gives you this great tutorial on setting the test reference. So you don't have to worry about someone like me telling you how to do it, because the equipment itself will help you out. So I have both pieces of equipment side by side. That's going to be the first thing that I want to look at. And you'll see here I'm using a 2-cable reference method with a bulkhead adapter between them. There is the loopback method when you only have 1 unit, and the other unit is with the other technician on the other end of the outside plant or the cable under test. You can also perform no reference, although you're not really going to be getting a very accurate reading. And then, of course, you can purchase reference grade test scores to produce repeatable measurements. That is obviously a recommendation by the manufacturer. Reference grade test cables tend to be very expensive, and the benefit of having them is there, but I guess it depends on what level of accuracy you really need. So most of the time we work around the side-by-side method. And basically, this little tutorial will run you through it. Here's the EXFO one-chord test method, just like we discussed. We're going to use the two-chord test method. And I've already got a couple of cables set up here, as we discussed earlier. And I went ahead and pre-scoped my ports on my 945 and my reference cables, as we discussed earlier as well. Don't want to take up too much of your precious time with watching me scope cable ends. Now, I have connected the reference cable to the source on the 945. Now I'm going to connect it to the meter side of the 945. Walk through the tutorial. I can see that reference, or that cable is referenced out fine. Now I'm going to disconnect. And using a bulkhead adapter, so you can see what I'm doing here on the top of my 945. Disconnect it to the other side of the meter. Everything looks good on those cables. Now, I've got the other end of my test equipment, which in the previous method we did a power meter and source. And now on the other end, I've got a portable, a Max 945 with a source and a power meter connected to those. Now, my reference method is telling me to connect to the actual source. So I'm going to disconnect from my meter and connect to my source. All right, now that I've got that connected, we're going to reference out those cables. And then you won't be able to see it via this screen because I've moved over to my other unit. Now the other unit is going to prompt me to do very much the same thing. So as you can see here on the 945, it's giving me the same, let's try to get some of the glare off there, giving me the same test reference method. So now disconnect to this guy and connect it over to my and I'll set the reference on this end. All right. Now everything's all finished up and I have a clean reference with my reference cables between the new units. Now I'll take this remote unit and you can see here that it is, says remote on it. I'm going to give this to my other technician and he's going to go out into the field to that fiber hut or to the customer premise location, and we're going to start doing some testing directly from the OLTS. So I've finished up there. I'm just going to quickly all right. Now that I've got everything referenced out, it's just a matter of performing the tests. So I can use multiple wavelengths. In this case, I have 3 options available. I could also use a single wavelength to lower some of my time, but ultimately 1310 and 1550 have been the gold standard. Since I have the option to do all 3 wavelengths, I'm just going to go ahead and start that fast test to show you how quickly we can perform both directions. So there's cable 1 in the A side and the B side. So our average loss, 23.45 dB. If we go back to our meter, I believe our stored reference was 24, 23 and a half, somewhere right in there at 1310. So that looks in line with what we had done before. But the big difference here is now this is an average loss. I have the loss from both directions, and I did it in one single test. So there's my references. Those are my verifications. Then here's the loss on the A to B side, 23.41 dB, and pretty similar on the B to A side. So having symmetrical loss is a good thing. We want to see that very similar loss going in either direction. And now that I've got both sides, I can just move on to the next cable. Now, if I want to go ahead, we're just going to say that this next cable is also all right. Forgot to hit store on that first one, so I'm going to store that first reference. Let's just say that I'm going to move it over to a different fiber that I'm using. And notice that we are now testing cable fiber number 2. So it automatically moved up to cable fiber number 2. And let's see, I'm going to go to my details. A little bit lower loss here, 22 on either side. On this plant, I actually have removed a couple of those bad splices. So I have 2 splitters and 1 kind of marginal splice in the network right now. And that seems to be in line with what I'm seeing on my tests. So I can go ahead and store that result, and then I can move over to the additional cable. Now, the great thing with the 945 is that we also test the fibers individually, and I have the option to go back and retest them. So if cable fiber number 1 failed, and then I come behind it and I run my OTDR on it, and I see, which I could just open up here. Actually, I have IOLM open. I could run a IOLM file or trace on that first fiber, identify why the high loss was there, fix it, and then now I can go back and actually test that again and keep all of the same results in the same test file. So as I was saying, it's a little bit anticlimactic as to what the 945s do, but the amount of time that it saves you from moving from one end of the fiber to the other end of the fiber definitely is worth the additional cost in a lot of ways. Also, just the ability to fix the fibers and then retest on that fiber if you're going behind and doing the OTDR, I think is really advantageous for a lot of folks. So the last method I want to talk about, and it's basically the same very similar, but we're going to use just the equipment that we have on board on the OTDR. So if you have a EXFO unit, get that out of the way, usually we will recommend, and I would say in most cases, unless you just need the very most bare bones unit, we definitely recommend having an onboard power meter and VFL. And these can become really handy for doing exactly what we did with this power meter, the PX1 and the FLS 300. The problem is I can't move these two pieces of equipment to two different locations. However, I could get in a pinch, I could use a loop up cord and test two fibers to see if I'm getting any high losses on either one, then switch the ends and test in the other direction to see where the loss is on that. So realistically, what I wanted to show here is just how to do this in a pinch. So on my FTB, I have an OTDR module, and within that OTDR module, I'm just going to switch over here to the FTB. And in IOLM, I can actually move over. So if you open up IOLM or the OTDR software, either way, you'll notice that there is a tab that says source. And essentially, this is just turning on the laser and using it as a fiber light source, just like the FLS 300. I'm going to turn that guy on, and I've got my wavelength set to 1310, and my modulation is continuous. So give me a second to reconnect some things. See what I'm doing here. Sorry. Use my FOA from my 945. Now that I've got all my cables connected and I'm using the IOLM as a source, I can go over to my toolbox and open up my onboard power meter. And I can see actually that I've got some loss already. So I connected this guy from the source of my OTDR and then through my plant, and now I'm in this fortunate situation of having both ends at the same location. And then from my back to the power meter that's on board on the OTDR. And what I'm getting here is the loss there. Now I can, of course, just as we did before, I can reference out those cables. There we go. I should have wrong. There we go. All right. So now that I've got those two reference cables connected, just in the power meter itself, set that reference to 0.
Hey, Eric, you want to change your wavelength on the on the power meter.
Thank you, sir. Yeah. So there's one final step. There we go. That looks a little better. Now we're going to set our reference. Perfect. Now when I go back, reconnect those fibers, I'll see about 24 dB of loss in the same on the same plant there. So going back to my camera here, you can kind of get an idea. So now you can see on board, I'm using the OTDR along with the onboard power meter, which is right next to your VFL. So if you don't have a separate power meter, and you do have one on board on your equipment, in a pinch, you can do a reference and use the OTDR as a light source. Now, of course, there's downfalls to this method as well. The biggest one being that I need to use a loop up cord or something along those lines and test two fibers if I want to get the signal back to myself on this side. So there's definitely a downfall there. Like I said, you can use it in a pinch if you do need to test a piece of the network. But I think of all of the methods that we use, the most popular and definitely the standard for insertion loss testing and optical return loss is going to be using the FTB 945 or the Max Series 945. You can see there that I've already connected back to that, and I can start another fast test. Any questions on insertion loss testing, reference methods, particular scenarios that you may have had some questions about? I see some things popping up. Got it. Charlie, are you seeing anything, sir?
I am not seeing any questions pop up at this time.
Well, I think that kind of brings me to what I wanted to cover. And like I said, the best online reference that is available that I've found has been the fiber optics reference guide. And there's several different sections on the difference between dB and dBm, for instance. We get a lot of questions about that. Measuring power and what relative power versus absolute power is. Good explanation on the reference guide there. And then if you have any new guys that are totally green to power testing, I highly recommend the virtual hands-on insertion loss testing as a reference guide, even if you're just printing this guy out for your test equipment. So Destry, good question. If your 1550 loss is higher than your 1310 dB loss, what do we have if we have 1550 loss versus higher than 1310? So as we stated before, we're generally, let's see if I have one available. I like to use our handy dandy business card here as a reference. So on the back, of course, scope clean scope, but we've got the attenuation at 1310 is 0.35 dB. Let's see if I can get that a little closer for you. Or at 1550, it's 0.25 dB. Not sure how clear that is for you guys, but basically that's the purpose of having that reference on the back of our business cards. So we know that there should be greater loss at 1310 than 1550. However, when you take, we'll go back here really quickly. And I'll show you why you have that. All right, at 1310, this reference cable looks pretty good for this this loss on only .1.12. Now, if I take that same cable and start to put a macro bend in it, suddenly my loss is at 6, roughly 7 dB. Now, if I move to
Switch to your overhead
here. Oh, thank you. Now, at 1550, let's see, I'll go back to 0. So at 1550, we've got roughly 3 dB. Oh, got to switch over my wavelength as well. So 0.1 dB at 1310. We'll go up to 1550, and we've got, should have a little less than that for this straight piece of, straight piece of fiber. Got it. All right. Now I'm going to go back to 1310, take a look at that. There we go. All right. Looks a little better, a little bit more loss, so the negative number is less loss. So now I'm going to attenuate this fiber and put a macro bend in it. I'm going to attempt to do this and change the wavelengths. So I'm going to move over to 1550 and look at that wavelength. Now I have a considerably higher loss than I did at 1310, and that's because of this macro bend that I put in the cable here. Because the 1550 wavelength is a larger wavelength and therefore cannot take this bend as easily as the 1310 wavelength. Therefore, I'm going to have more loss on 1550 than 1310 versus what we should have, which is more loss on 1310 than 1550. So that's where basically what you're encountering. Now, you may see that situation in a splice case or something along those lines, or close to a connector, and you see both reflection and loss higher at 1550 versus 1310. And if that would be, say, if you're looking at it on an OTDR, that may be a single event that's combined together. And typically we see that because usually wherever there's a connector, there's a boot or some kind of cable plant behind that, and a lot of times that's where we see a macro bend. So looking for higher loss at 1550 close to your connectors is a good indicator that you've got a macro bend in your case or at your cross connect or something along those lines. So hope that answered that, Destry. Any other loss questions or items that you guys might be seeing that are unusual, or you're maybe have some questions on, or on the equipment itself? Well, I guess if that's all, folks, then I'll let you have 5 more minutes of your day back. It brings us to 10:55. So thanks everyone for joining. Hope I cleared up some issues on referencing cables and what have you. If you guys have any questions, feel free to reach out to myself or anyone at SNS. And also, like I said, we'll be sending out a great some links to the FOA references. I think this usually clears up a lot of questions and has some great definitions of the various terminology that we use that a lot of times gets confusion. So thanks everybody. Appreciate your time.
Thank you, everyone. Like you said, we will be sending out some information along with a link to the recording. So if there's anything you want to go back and reassess or look at that Eric had said today, you will be receiving that here in the next day or so. With that being said, we will let everybody have a good day. Thank you.